This conference will now be recorded.
All right, this is the 6.2 trigonometric functions of angles continuation video. We went through most of the topics today in class and finished those up, but we skipped a couple examples that were similar, so I'm going to work through those on this video. So for the first one we need to do, I'm going to scroll down to this slide right here. It's slide 7 of 17, and we needed to find the, excuse me just a second. No, we need to find the exact values of the trigonometric functions for the acute angle. We did 19 and or no 21 in class, so we're going to do 17 and 19 real quick. So this says sine of theta is 3/5. They said it was an acute angle, which means we're in quadrant 1. So if you imagine drawing this with your angle theta coming away from the origin, kind of draw a triangle here for that. Sine is opposite, which would be side over here, so that's 3 over height. Now we need to use Pythagorean theorem to solve for the missing side. So that would be, these are our legs. So this would be, let's call that a squared plus b squared equals c squared. So that's a squared plus 9 equals 25. Subtract over the 9 and we get 16. So that means this side, when we take the square root, is going to be 4. So now that you have all three of your sides, you can write your trig ratios. So sine of theta we already knew was 3/5, which means you also already know cosecant, which is the reciprocal of that, so 5/3. Cosine of theta is adjacent over hypotenuse, so that's going to be 4/5, which means secant of theta is going to be 5/4. Tangent of theta is, let's see, opposite over adjacent, so that's 3/4. And cotangent then of theta would be 4/3. Something I don't know if I said in class, but I want to make sure we say it sometime, is that if you don't put the theta or the actual angle, if you know its name, here sine equal to a ratio does not make sense. It has to be sine of a theta or an angle, essentially. All right, let's look at tangent of 5/12. Again, this is an acute angle, so it's in quadrant 1. Tangent means you know opposite over adjacent, so that would be 5/12 to this theta right here. So 5 and 12 are the legs, so this would be 12 squared plus 5 squared equals c squared. We're solving for the hypotenuse. So that's 144 plus 25 equals c squared. Add those together, you get 169. So if we take the square root of that, it comes out to a nice number of 13. So sine of theta is opposite over hypotenuse, so that'd be 5/13, which means cosecant of theta is going to be 13/5. Cosine of theta is adjacent over hypotenuse, so that's going to be 12/13, and then secant would be 13/12. Tangent of theta is already known, it's 5/12, which we could also see from our picture, which means cotangent of theta is 12/5. So that's the other two from that slide that we did not do. Okay, let's look at the next slide because we did 24 in class, but we did not do 23. So for number 23, let's draw out what we think we should for this picture. The height of a tree. So a forester is 200 feet away from the base of a redwood tree. So here's our tree. Yeah, that's a bad tree. And he is 200 feet away from the base. So here's our little forester dude. He observes the angle between the ground and the top of the tree, and he observes that that is 60 degrees. He wants us to estimate the height, so we're looking for this over here. Now, this would make this we're assuming that all trees are perpendicular to the ground. I know that's a big assumption, but we're assuming this then is a 30, 60, 90 triangle. So in a 30, 60, 90, the side across from 30 is always kind of our base side. And remember, the hypotenuse is double that, and the side across from 60 is this on the square root of 3. So that makes this 200 on the square root of 3, and that is in feet if we want it as an exact answer. If we want the approximation, we would type this into our calculator, and I'm going to round to, since they didn't specify, I'm going to round to a whole number. This is approximately 346 feet for the approximation. Because that's normally what you would tell someone instead of saying, my tree is 200 on the square root of 3 feet tall. All right, we did the one on number 9. We did both parts of slide 10. We did 11 and we did 12. So that gets us into this last little subsection. We talked about how sine, cosine, tangent, cosecant, secant, and cotangent, if you place things in standard position, which means the angle is at the origin, then the legs of the triangle are the point. It's x and y. It's the actual point of this point right here on the angle. And that means that this is length x, this is length y, and then the hypotenuse we can think of as kind of a radius of a circle, so r. So if you think of it that way, those are your sides of your triangle, and we can redefine sine, cosine, and tangent using letters x, y, and r. And the reason that's helpful is because if you're on the quadrants, like the x-axis or the y-axis, if you're either on either of those, you don't really have, three sides of a triangle. You just have a length r and an ordered pair. So that's how we use those. And I believe we did both of these in class. Yes, and so that put us here. And we talked about all science teachers are crazy, or you can memorize this by all students take calculus. This tells you which quadrants you have positive trig values in. So every trig, all 6 trig values are positive in quadrant 1. That's because all of your hypotenuses are always positive and your points are all positive. In quad 2, the only thing that is positive is the sine cosecant family, because remember, those are reciprocals of each other. In quad 3, the only thing that is positive trig values are going to be tan and cotangent. And in quad 4, the only thing that's going to be positive is cosine and secant. Now, we did this one together in class, so that leaves us with the last 2 slides to go through. So I'm going to take you through this. This is where they give you 2 pieces of information. One of them is an actual ratio. The other one is something about a trig ratio, like is it positive or is it negative? So let's talk about this for a second. So sine theta is 3/5. That's a positive value. So sine is only positive in either quads 1 or quads 2. You have to determine where to draw your triangle, or this will not give you the right ratios, because sometimes you are going to get some negative answers. And tangent is negative. So let's look back at this slide. So remember, tangent is positive in the 1 and the 3. So that means tangent is negative in 2 and 4. So I'm going to write that tangent would be less than 0 in 2 or 4. The quadrant you draw your picture in is the one that they have in common. So if I go to draw a picture here, I'm going to draw me a triangle coming away from the origin and then going down to the x-axis in quad 2. And then that tells you how to label this. So it says sine is 3/5, and notice it's positive. So 3 makes sense for opposite, and it's a y value. They're positive over here, and the hypotenuse is always positive. The thing you had to know, and why you would get this wrong if you did not get this in the correct quadrant, is that your x value, even though when we solve the Pythagorean identity, it comes out for a negative value since we're in quad 2. So when we go 3 squared plus b squared equals 5 squared, this is 9 plus b squared equals 25. So b squared equals 16 when we subtract. But remember, when you take a square root, it is plus or minus. In this scenario, it's going to be the negative because we're in quad 2 and x's are negative in quad 2. So that's a -4. Because remember, this is related to this length on that. So then we go to do our trig ratios. We already know sine of theta is 3/5. That means that cosecant of theta is 5/3. Cosine of theta is adjacent over hype, so -4/5. Secant then would be -5/4. Tangent of theta is opposite over adjacent, so that's -3/4. And notice cotangent theta is -4/3. So notice the only thing that came out positive in quad 2 was sine and cosecant. So that does prove that little theory we had from the other part. Okay, and then that leaves us with these. These are all the same thing. We're just doing different variations of the same, which trig value did they give you? So tangent is negative if we're in quad 2 or 4, because it's positive in all and teachers, which were the first and the third quadrants. Sine is positive in quad 1 or 2. Again, go back to your picture to verify that. So the thing that these two have in common, again, is quad 2. So where I'm going to draw my picture is in quad 2. And I'm going to label this as, remember, opposite over adjacent. Now, you don't know which one of those is negative if you don't get your quadrant correct. In quad 2, the negative is on the x one. So this is 3 over negative 4, opposite over adjacent. And again, this is going to come out to 5 because we've seen 3, 4, 5 is a normal Pythagorean identity triangle. But you can do the Pythagorean identity to prove that. So this is going to be sine of theta is opposite over hype. Cosecant then is the flip of that. Cosine is adjacent over hype. Secant would be the flip of that. This is pretty much the same one we just did. Tangent of theta is opposite over adjacent, and cotangent of theta is the reciprocal of that, so negative 4/3. Okay, so let's do one that's not as obvious to us. This says cotangent is 3 over 4. A lot of times when I see that, I'll immediately go ahead and write it as tangent because most people are more comfortable with sine, cosine, and tangent. So this is a positive tangent. Remember, tangent is positive if we're in quad 1 or 3. The reason tangent is positive in quad 3 is it's negative over negative. It's a negative x and a negative y. Cosine is negative in quad 2 and 3 because that's when you get negative x values. So it looks like quad 3 is the common thread. So that's where we're going to draw my triangle. Okay, so I know that I'm going to look at the tangent because that's easier for me than the cotangent. This is opposite over adjacent. So it's 4 and 3, but because we're in quad 3, they're both negative. And that makes sense because two negatives together would make a positive 4/3. And again, this is the same triangle, except remember hypotenuse is always positive. So it's going to be a 5 again. So sine of this theta is from this angle right here is opposite over hype, so that's negative 4/5. Cosecant of theta would then be negative 5/4. Cosine of theta is going to be negative 3 over 5. So secant is going to be negative 5 over 3. Tangent should come out positive, which we already know it is. It's 4 over 3 because it's negative over negative, and cotangent is 3 over 4. Those two were strictly given to us just from this. Okay, last one of this 6.2 notes. So this says sine is a positive 2/5. Remember, sine is positive in quads 1 or 2. Cosine is also positive. Cosine is positive when the x's are positive, so in 1 or 4 for ordered pairs. So it looks like this is going to be drawn in quad 1. And this one does not have a nice relationship for the sides. So this is a 2 and this is a 5 because opposite over hypotenuse for sine. So when we go to find the other side, it's going to come out as a square root here because this would be 4 plus b squared equals 25 if we plugged it in and squared those parts. So that's going to be b squared equals 21 or b equals square root of 21. And this time it is a positive square root of 21 because we're looking at it in quad 1. Where all x's and y's are positive. So then when we go to write it out, we already know sine was 2 over 5. That means cosecant is going to be 5 over 2. Cosine of theta is square root of 21 over 5. So that means secant is going to be the reciprocal of that. You should kind of have gotten down a pattern here. When you flip it, the square root ends up on the bottom, but then you rationalize it. So you always end up getting the square root over itself. And then tangent of theta is going to be 2 over square root of 21. So we're going to have to rationalize that. So that'd be 2 square root of 21 over 21. And then cotangent would be, remember, just the opposite. So it'd be square root of 21 over 2. All right, that's the end of the 6.2 video. That catches us up completely on that. And remember, I'm doing a partial video for 6.3 to kind of jumpstart us and get us back ahead of how far behind we are. So hopefully you guys enjoyed this and you can watch it as many times as you need. Let me know if you have any questions.